morning, students. I have tried various ways to do the recording, and finally we are here. So, in this class, we are going to study transfer function of mechanical systems. You know about transfer functions, Asha teacher has told you. So, let me quickly recap how to find transfer function. So, there are various steps. This class I will do it very slowly. I want all of you to understand. So, I want all of you to do well in the exam, and at a higher end you have seen few things in the last class, your presentations. To analyze anything, we want a model, and one such model is transfer function. So, the first step is identify the input and output of the system, say ut and yt. This is usually a trivial step, but some cases it may not be trivial. So, it is important. Step 2, obtain, this is a hard step, okay, because you should know other things also. Obtain the differential equation representing the behavior of the system using physical laws governing the system. So, if you are studying mechanical system, you should know the Newton's law. If you are studying electrical system, you should know KVL, KCL, etc. So, you can write equations. These equations are differential equations. Step 3 is easy. Take Laplace transform of the differential equations. So, only minor knowledge in Laplace transform is required. That is, if Laplace transform of y of t is y of s, Laplace transform of d by dt of y of t will be equal to, I will pause for a while, you think? Yes, you got the answer, it is s y of s. So, you have to find Laplace transform of the differential equations, and step 4 is rearrange the term to obtain ys by us. So, you have learned that transfer function is Laplace transform of the output y of t by Laplace transform of the input u of t. So, we want to, this is our objective. So, let us consider a very simple example. This is a very simple mechanical system. You should know the dynamics of the system. You know that if you pull this mass, what will the mass do? There is inertia for mass. So, the inertia will exert an opposing force, which is equal to m into acceleration, m into a. You know a is dx by d square x by dt square, or x double dot. And what is usually spring will do? This end of the spring is fixed. So, when I try to pull the spring this side, it will have an opposing force kx, and the damping, it will oppose velocity. So, it will exert a force b x dot. So, let us try to do this problem. What is step 1? Identify the input and output of the system. So, input is force. Force is the input. We are giving it as input. We are doing something on the system. And what is the response? Output is the displacement of time. We want to know how, when you apply a force, how will be the displacement. So, let us assume few variables. Displacement be x of t, velocity be v of t, acceleration be a of t. So, these notations are quite familiar to you. Then, what is the step 1? Identify the input and output. What is input? Input is f of t, output is x of t. Step 2 is obtain the differential equation. So, when I apply a force F here, the opposing force is mx double dot, bx dot, and kx. So, let us see that. So, this is the equation mx double dot plus bx dot plus kx dot. So, we have done with step 1 and step 2. Now, we have step 3, you have to take the Laplace transform. So, we have the equation mx double dot plus bx dot plus kx dot equal to f of t. I applied Laplace transform on both sides, Laplace transform on the left hand side and Laplace transform on the right hand side. So, let Laplace, we do not know force. So, let Laplace transform f of t be f of s. and let Laplace transform of x of t be x of s. Then when I substitute Laplace transform of f of t is f of s, Laplace transform of m x double dot is m s square x s, Laplace transform of b x dot is b s x s, Laplace transform of k x s k x s. So we got to this. So we are done with step 3. Step 4, rearrange the terms to obtain the transfer function. So I want, in your mind you should know that we want x of s by f of s. So in this it is very easy. You club all the x of s together and put all the f of s together. So let us see that. So if I take x of s outside this bracket, I get this equation. Then we got the transfer function. So I hope you are happy. In the next module, we will see a little more complicated system. For that, we require some more knowledge. That is, if the spring is free at both ends. So here, in the earlier case, my x1 was 0. I will keep this A fixed. So when I pull the spring, what happens? There will be an opposing force kx2. Suppose you imagine that x2 is 10 centimeter and x1 is 5 centimeters. x2 is greater than x1. So I am trying to pull the spring. So the net displacement for the spring is 10 minus 5. So when I am trying to pull the spring will get compressed, and the compressive force will be equal to k into x2 minus x1. So if both ends are moving, if I apply a force F, the opposing force will be k into x2 minus x1. So the fixed case is a special case where x1 is 0, then in that case F is equal to k into x2. Similarly, for dashpot, if I apply a force F and if the displacement is x2, the velocity will be x2 dot, this velocity will be x1 dot, and opposing force will be b x2 dot minus x1 dot. So this problem we will do after a short break. So I have been experimenting with, on a lighter side, I have been experimenting with OBS. I tried many trials and finally I think I have got it. So let me stop recording.